everyone. Today I'm going to talk about the continental oceanic convergent plate boundary. If you understand the previous concept, then it is going to be very easy for you to understand because this concept is very familiar with the oceanic convergence. Now, the name itself specifies that the oceanic plate and the continental plate are going to collide with each other and create a convergent plate boundary. This convergence also known as a Cordilleran convergence. Why? Because it gives rise to extensive mountain system. That's where it is different from the oceanic convergence. In that convergence, when two plates collide with each other and created a convergent plate boundary, they also created a trenches plus volcanic island arcs. But here it created a continental arcs, means a chain of volcanic mountains. As usual, the denser plate going to subduct under the less denser plate. Out of these plates, oceanic plate is more denser than the continental plate, and it created a zone of the subduction. This process forms the trenches at the subduction zone. Now, here comes the interesting part. The trenches formed here are not as deep as in oceanic convergence trenches. We know that they form a continental arcs. But what are continental arcs? Let's find out. As we know that when oceanic plates subduct into the mantle, under high temperature and pressure, that plate melts into a magma. The density of the magma is lower than the crustal density. So that's why that magma finds its way to upper direction in continental crust. As a result, the continental arc develops, means a chain of volcanic mountain running parallel to the trenches. Whenever the oceanic plate involved in a convergent plate boundary, the formation of the trenches at the subduction zone and triggering of many geological processes like volcanic activities and earthquakes are common. We find out that despite the similarities with the oceanic convergence, there is slight differences, like the formation of the continental arc or a folding mountain at the plate boundary. Now let's find out what are the excretionary wedges. When material of the oceanic plate is being dragged down to the mantle, other sediment that fall on the trenches are also piled up to the foam, which is also known as the excretionary wedges. These wedges consist of a material eroded from the sinking plate and may add more complication to the structure of the continental margins. This buildup continues to cause a crustal shortening and may usher a further phase of folding and lifting of a nearby terrain. Also remember that the pressure offered by an excretionary wedge folded the volcanic mountains, raising the mountain significantly. Let's explore some examples. Let's start with the formation of Andes. The important thing you have to remember in formation of Andes are plates that are involved, like Nazca Plate subduct under the South American plate. Also, the Peru-Chile Trench formed in the subduction zone. Ozas del Salado, which is active volcano present at the Argentina border, and it is highest active volcano. Formation of Rockies. It is slightly different from the Andes. The plates which are involved in the formation of Rockies are Juan de Fuca and Pacific Plate subduct under the North American plate. Now here the difference. While subduction, the oceanic plate is less steep, and because of that, Rockies are formed at a distance from a continental margin. Trenching is a little difficult here as the boundaries are filled with the excretionary wedges. There are also presence of a series of fold zones, like San Andreas Fault also present here, which make it a different from a Andes formation. Now here's the thing you have to remember. Folding mountains are present at the boundary of convergent plate boundaries. You can also see the map. There are multiple examples of folding mountains. With that said, let's conclude the video. I hope you like my videos, and if you have any doubt, please comment it below. For further videos, please like and subscribe my channel.